So in this video, we'll see how to create a link checker, and in the process, we'll see how concurrency works in Go. So we'll tackle a task to uh, check multiple URLs that if they are working fine or not, and we'll do this using two concurrency methods. One is called worker pool, and the other is called semaphores. So I'll illustrate both of them and how to use them in this video. So this is a fairly empty uh, directory. I mean, it has just a main.go file and a go.mod file. Okay, so in the go.mod file is empty, a simple module. You can create this using go mod init command. That's fairly basic. And this is a main file, and it has a function get URLs. We can change this to dynamically read the URLs from a file, or it may parse an HTML page and extract all the URLs in it, and so on. But for this video, to keep it simple, I have created a hard coded list. Okay, so let's first create the sequential function. I mean, a function that will sequentially loop through all the URLs and try to uh, make an HTTP GET request on those URLs. Okay, so this is a pretty straightforward function that will get that will make GET request on all these URLs one by one and print the status code if they are successful. And to make things more uh, visible, I mean, to see if the concurrency enhances the time or not, I mean, it improves the performance or not. I'll just create a start timer, and I'll print that it is the program executed in uh, so many seconds or milliseconds, however time it takes. So let's try to run this. So it will take a bit time, around 10 to 15 seconds. Last time I checked. Okay, it took 14.47 seconds. Now, the easiest way to improve its performances by right. So one thing we can do to make it easier is to create a function which makes the get request. We'll cut this and we'll create a function check URL, and I'll pass the URL string, and I'll just paste it, and instead of continue I'll just do return. Okay, and we'll call the check URL each time. Let's try and see if it runs the same way or not, if we didn't break anything while refactoring, just to be sure. Okay, it's working fine. Now let's try to add some concurrency to it. The easiest way is to add a go primitive before the function call, but as you may know, it won't do anything, because uh, as soon as this main go routine finishes, the program stops. Meanwhile, there is nothing to wait for these background processes that we have spawned. For that, we use wait groups. So I'll create a var of a wait group, and before creating a background routine, create we'll add a routine in the wait group, and we have to pass weight group. I'll tell you how we can simplify this using weight group, and we won't need to change the signature of this original function. I mean, it is a new add-on in this Golang, but this is the traditional way. Okay, so and here before printing we'll do wg dot wait. I'll just explain what does this wait group do. So here we have created a wait group variable, and before creating each background routine, we add one. I mean, if we would create let's say five go routines in the background, we'll add five. But since we are doing one, so we are adding one, and each time this check URL function finishes its task, it calls the wg.done function, so which again decrements. So internally, wait group has a counter variable. Each time we do an add, it increments the wait group, and when the wg.done is called, it decrements. And wait group dot wait waits for this this counter to be zero. Okay, so this is how wait group works. So let's see how it works. So it executed in 2 seconds. So but there is one problem, that if there are let's say thousands of URLs, so it will spawn 1,000 um, get requests, and it may cause harm to your system resources. So to avoid that, we use controlled routines. I mean, controlled concurrency. So one way to achieve that is worker groups. Before going into worker group, let me simplify this check URL and how we are using the go keyword. Instead of adding and calling the wg.done, there is an helper function which is called wg.go, and inside that it takes a function which has no input and no return type. And since we are using this, we don't need to pass the wait group, and also we don't need to call wg.done. Basically, what this wg.go does is before executing this internal function, it calls wg.add, and when the function is done, it calls wg.done. So this is just a shorthand notation for the same. So let me demonstrate that it works the same way as it used to do before. Okay, now let's go to the worker group. uh, I mean the worker pool method. So workers are basically background functions that take input from a channel or a queue, you can say, and pick up the task in the queue and do them simultaneously. I mean, if there are five workers, they will all observe a channel or a queue, and and pick up tasks from them one by one and execute them and pick up, and this is called a worker pool. Okay, so to do that, what I'll do is I'll create a channel. Okay. And instead of passing the URL, I'll pass in URL channel. Okay. And I'll do some changes here also. And instead of calling it one channel, what I'll do is I'll pick up URLs from the URL channel. Okay. And rest everything will be same. I'll explain you once again what is happening here. Sorry, arrange. And instead of adding URLs, I'll create how many workers we need. Let's say we want five workers. Okay. And we'll pass all the channels, all the URLs in this in the URLs channel, URL channel. I mean, okay. Okay. So and at the end we'll need to close the channel. Okay. Now let me explain what we are doing. A channel is basically a way uh, to to pass data. Okay. So here we are passing the URLs into the channel, and in this for loop we are extracting the URLs from the channel. Okay. So here like five parallel workers have been spawned. Okay. And they all are observing this URL channel. So as soon as there is a URL input inside this channel, one of these five workers, whoever is free, picks up the URL and starts making the get request. Okay. And also this loop will end only and only when this URL channel has been closed. Okay. So always remember to close the channel when a for loop is acting on it. So this is line is, or else it will get stuck in an infinite loop. So let's try to run this. So it will be more than 2 seconds, but less than 10 seconds, right? So let me change it to one. So it should result in about 10 to 15 seconds of time duration, because it is like a sequential get request. Okay. And if we do it for 24, I mean, as many URLs are there, then it will be executed in 2 seconds or so. Okay. So that was the worker pool. Now let me undo the changes. I mean, when we were having um, as many go calls as there were URLs. Okay. Okay. So now we'll get into semaphores. So semaphores are basically a data structure that is used to coordinate between multiple parallel processes. So execute the thing, like implement the logic, and then I'll explain what is happening. Okay, I'll create a sem variable. Okay, so this is all we need to do. We created a sem channel, it is a buffered channel. It has 5 slots. Okay, so what is happening here is, when there are 5 slots empty, the first line fills up one of these slots. Okay, then it goes into the check URL function call. Okay, and uh, meanwhile that check URL is being executed, another background process is spawned, and it fills another slot, and then again it makes a request to other URL, and so on. So but when all the 5 slots are filled, this line gets stuck. I mean, this line is not executed until there is one empty slots, and when will there be an empty slot? When the check URL is completed, it goes into this statement. So basically, this statement pulls out one object from that slot and empties it. So now when this slot is empty, one of the go routines fills it again and executes the get URL function. Okay, so this is how it's working. So it limits number of parallel requests that are being executed in the using this semaphore. So let me execute this and show. It should take 3 to 4 seconds, I guess. Okay, it's taking less. Let me decrease it to 2, let's say. This should take more time. Okay, and let's change it to 24, and this should take about 2 seconds or so, because there are as many parallel threads as there are URLs. Okay, so this is a semaphore, and one easier way to achieve this is error groups. So under the hood it works the same way, but there is but it has easier syntax, basically nothing else. Error group dot group. So but there's one thing that we have to add this inside our module. Go mod tidy, and it will download this module. Okay, so basically this is not inside the standard Go modules. It is in development or extended module, basically. So yeah, so instead of WG we have to use G, and it returns an error. There's just one difference, and for now we'll return nil, because we don't need an error. And instead of G we are using instead of WG we are using G, and it returns an error. We can ignore that error. And just one thing, limit, set limit. Let's say I set limit to 5. Okay, now let me execute this. Okay, it took 3 seconds or so. Let me change this to 1, and it should take about 10 to 15 seconds. It's like one process at a time, one API call at a time. And then I'll change this to 24 and show you how much time that takes. So basically error group at the back only executes the semaphore method, but it has an easier syntax. So I showed you how this works. So that was all for this video. I hope you learned something new, and do like, subscribe, share if you like, and thanks for watching.